So here's some examples of from this fourth section in chapter 4, and these are the big ideas that they say is important. Say are important, and change of base we talked about just the last one, and that exponentials and inverses kind of been working along, right? Rewriting logs to exponential form and taking an exponential form and rewrite it in log form. We talked about that. What's new here is the sums of log property, the difference of log properties, and then we're going to use those properties to solve an equation. In calculus, it's easy. It's often easier to rewrite. They give you this awful looking thing you got to deal with, and it's easier if you can rewrite it sometimes into a sum or a difference, or condense it to get a single log. And so that's what we're going to look at. So they want us to expand this. So there's some properties you ought to write down. You ought to write down that the log of some base raised some exponent. We've done this, and I did this in this section before. You can just bring that when you're taking a logarithm. You can just bring that exponent down in front. It doesn't have to be a variable. It can be a number, but that helps you rewrite something we learned, and you did some work last section that made it a little easier to rewrite those to get the exponent out of being an exponent. So that's the power, the exponent property for logarithms. The sum of log property, well, if you have a logarithm, and I'll just leave it log base 10, and you're multiplying two things, and sometimes they'll put them in parentheses, sometimes they won't. What you can do is you can rewrite this to two logarithms, log A plus log B. Okay, so if, and sometimes that makes it easier to deal with. It can be any base. You'll keep the base the same. I mean, if this was base 2, you'd want to have a base 2 here, base 2 here. What you don't want to do is and we can go backwards, and that's what you don't. Where you got to be careful. This expression doesn't say that I can take the log of A and multiply it by the log of B. That's not the same expression, so you don't want to do that. And the other area that people get themselves in trouble with is if I have the log of a sum. That's not the same thing. Okay, notice that this is the product of two things, and this is the sum of two things. So don't try to break this apart. You can't. That's kind of locked up. You got to deal with it the way it is. If it's an equation, you got to try to think about rewriting it to get rid of the log. Okay, so let me do some erasing here. So that's the sum property. Now the other property that is handy is that when you're dividing two things, and you're taking the log of them, you can actually subtract the two logs. Take the log of one, the log of the other, and subtract them. And that will give you an equivalent expression. So what we're trying to do with this exercise or this problem is to break it out into a string of logarithms. So I see a 5 times an x to a second power. I'm going to be able to use the sum property and that exponent property. The other thing I want to point out before I do this is notice it's only the x that's being raised to the second power, not the 5. And that whole mess is being divided by a y to the 4th. So that's going to say, well, we're going to be able to do a subtraction here. And again, use that exponent property. So to do this problem, I'm going to write log 5 plus, now I'm going to write 2 log x. And I hope you understand that what I did is, because these two things are being multiplied, I wrote them as the sum of two logarithms, and the x has that exponent of 2, which I just brought down in front of the log. And now for the last one, because it's being divided, I'm going to go minus 4 log y. And the 4 is in front because of that exponent. I can bring it down in front of the logarithm. And I subtracted it because it's this thing divided by this thing. So the log of this divided minus the log of that. And that's fully expanded. We can't take that out any further. We're done. We did what they wanted us to do. So now we're going to go backwards with a log sum property, right? Here's a sum. I've got an exponent in front, so which I can bring up and bring in front for the x and for the y. So I'm going to just write this as a single log. It's going to be x to the second power times y to the third power. Put parentheses around it if you want. So that's how we deal with that. So now we're going to start using these properties to solve equations. What I'm noticing here is there's a subtraction sign between these two logs. So that means I can it'd be really nice just to have the one single log. So since I'm subtracting those two logarithms, I can write x plus 5 over x as a single logarithm, and that's equal to 2. Now I still have a log. I don't want to have a log. Logs can be a pain in the butt, so I'm going to get rid of it by taking that 10, this is the base 10. There's nothing written there. I'm going to rewrite this as an exponential. So it's going to be 10 to the second equals x plus 5 over x. And then of course I can think of 10 to the second as being over 1. So that leaves me 100 over 1 equals x plus 5 over x. I have a proportion which you've been solving for many years. You're just going to find the cross products. So I've got 100x, 100 times x equals 1 times x plus 5. Then I'm just going to solve this for x by moving the x's all on one side of the equation. Then I'm going to divide by 99. And 5 over 99 is the answer. Why did I write 95? 5 over 99. Okay, so that happens when you're subtracting two logarithms. Here we're multiplying two logarithms, so that tells me I can rewrite it as a single log, but I'm going to multiply those two things. X times x plus 3 equals 1. So again, I'm going to get rid of the logarithm by rewriting this as 10 to the first equals x squared plus 3x because I'm distributing that through. Now I'm seeing a quadratic equation in x squared. So 0 equals x squared plus 3x minus 10. Now we should try to factor this because actually this one doesn't factor too badly. If not, you're going to just do this, use some quadratic equation solver to find, using A, B, and C. So let's see, in order to get a positive 3 in the middle, I need to have 5 minus 2, and that checks. Okay, so then we know these are both equal to 0. So if it's x plus 5, when is that equal to 0? When x equals negative 5. And the other one is when x equals positive 2. Now here's the twist. You got to come back up here. Look at your original equation. I can't take the log of a negative number, right? I don't know if I've said this on a video. Why can't I take the log of a negative number? This is saying log of negative 5. Why can't I crunch that into a calculator? Well, if I rewrite this as 10 to the x equals negative 5, and I know the graph of 10 to the x looks like this, it's always positive. It approaches that horizontal asymptote, y equals 0. So that graph will never cross the line negative 5. So I can't I can't raise 10 to a power and get it to be negative 5. So this is an extraneous root. We want to ignore it. Just work at the positive 2. I'm going to ask you this in a multiple choice question where one of the multiple choice answers will be the negative 5 and the positive 2, and I want you to be able to understand that. You got to look at the originals and look for those extraneous roots. Okay?